Robert, how are you?
I'm doing great. And
All right.
today what I would like to do is explain to you an incredibly simple and cost-effective way of reducing poverty in rural Africa by using a solar water pumping system. So first let me explain what the problem is. The problem is there's millions of men and women, many times women in rural Africa who have to uh, water their gardens in the dry season by hand. And the reason they have to water their gardens in the dry season by hand is, first of all, incomes are only about $1 a day or $2 per day. So they can't afford the diesel for a diesel pump. And they can't afford, they're in places where there is no electricity. So what they wind up doing is carrying water for their gardens in a watering can. Now, can you imagine how much work it takes if you're trying to irrigate a quarter acre or an acre with a watering can? You're spending all day carrying water from a water hole to your garden in order to water the garden, okay? And so that means during the dry season, they aren't making very much money because their gardens are incredibly tiny. And if instead of having to carry the water in a can, they could just pump the water in a hose, it would make life so much easier, so much easier. So what I'm going to do is I'm going to show you a very simple and effective way of using solar energy to pump the water in a hose rather than carry it in a can. So first let's go over here, and the system we have is really simple. It takes two 100-watt solar panels. You can buy each of these solar panels at Home Depot for less than $100. And in Africa, what we do is we bring them over by container. If we bring them over by container, we can get them for 30 to 50 bucks each. Okay, super cheap, 30 to 50 bucks each, $100 for a couple solar panels. Okay, what do you then do with the solar panels? You want to use the solar panels to power a DC pump. This is a DC pump. And what a DC pump is it has a little rotating, called an impeller, sort of like a water fan that pushes the water that sucks the water from the bottom and pushes it out the hose right there. It works on DC electricity. And the beautiful thing about a DC pump is that as the electricity supply goes up and down, it doesn't turn off or burn out. It just increases and decreases the flow rate a little bit. The other beautiful thing about using a solar water pump is that it's incredibly well matched to what you need for your garden. Your garden uses the most water on hot, sunny days. The solar pump produces the most water on hot, sunny days. When it's cloudy and rainy, the pump doesn't produce very much water, but your garden doesn't need water either. So it's a perfect match for the requirements of the millions of Africans who are trying to grow gardens using a little bit of irrigation. So now let's see how the panels hook up to the pump. I'm going to put the pump back in the water here. And that pump is meant to take 60 volts. I'm going to demonstrate how it works perfectly fine with less than 60 volts. What we do here is each of these simple 100-watt panels have about 15 to 20 volts. So let me measure that here for you. So one panel, I have a voltage measurement here. And one panel is 19 volts, 19.7, close to 20 volts. The other panel is exactly 20 volts. So what we do is we hook those two panels in series. To do that, we connect the plus of one panel to the minus of the other panel and see what the total voltage is. The total voltage of the two solar panels put together is 39.8, basically 40 volts. So now what we're going to do is we're going to hook the pump, which is rated up to 60 volts, to this 39.8, this 40 volt power supply. And when we do that, we sort of twist that here. And because it's now drawing current, it's dropped from 39 volts to 36 volts. So we have a 60 volt pump operating at 36 volts. And let's see what the pump is doing. So we go over here and we see, even though it's rated at 60 volts, the pump is operating perfectly fine, right? So it's filling up the pipe with water, pipe's going up the hill, coming back down. You can see the flow rate of the water. You pull it out of the water, the flow rate stops. You put it back in the water. After the bubbles work themselves out, the flow rate should start up again if I get all the bubbles to work out. And here we go. The flow starts up again. To show you how much pressure there is, you can squirt it. So you can see there's enough pressure to send it up 10, 20 feet. What that says is, even at only 36 volts operating voltage, we could pump this water up a 10 to 20 foot hill and irrigate a garden. So how does this compare to carrying water with water cans? We can do that. Imagine you take a water can, you dip it in the watering hole, and you go water your garden. It's going to take at least half a minute to a minute to take this can over to your garden and dump the water out over your plants. Let's dump this water out and compare that to the flow of the pump, right? So when we put this in the flow of the pump, what happens? 1001, 1002, 1003, 1004, 1005. Less than 5 seconds, that solar pump pumps as much water as one of these watering cans. So if it's going to take you a minute to take it to the garden, and this pump delivers the same water in 5 seconds, that increases the productivity of your labor by a factor of 10. That now means if you're limited by labor in terms of irrigating your garden, theoretically, you can irrigate 10 times as much garden. Now, in practice, you won't take advantage of that full factor of 10, but data we have from people who have tried these pumps in Malawi indicates that they increase their gardens by a factor of 4. So imagine you're irrigating just a fraction of an acre. You increase that acreage by a factor of 4, right? Now, instead of making a few $100s every 90 days, which is a typical irrigated growing season, you're now making $1,000 or $2. So the payback is $500, $1,000, $2,000 for a little solar pumping system that costs less than $300, maybe even less than $200. So you are paying back the investment of this solar pumping system in a matter of 1, 2, or 3 months. Now imagine that we get donors to help pay part of the cost so this is affordable to everybody in rural Africa. For every $100 that the donors use to subsidize the cost of this system, Africans will be making thousands of dollars a year. Now, is that a way to reduce or eliminate poverty or what? Right? If every dollar we donate produces $10 per year for some of the lowest income folks on the planet, then we really have a chance to make at least a piece of African poverty history. And I don't know, I'm a physics guy. I'm a physics guy who's been traveling back and forth to Africa for 30 years. I see this and I look at the billions of dollars of other aid programs and I say, hey, just throw a few $1,000,000 at this and we can make millions of people happy.
No, Robert.
And
Robert,
I don't understand why we can't do this.
let me ask you. So you said you're a physics guy. So could you explain that? What do you mean when you say you're a physics guy?
So both my parents were math geeks. So I'm the son of 2 math geeks and I like science and nature. So when I went to college, physics is the most mathematical of the sciences. So when I went to college, I double majored in math and physics at Berkeley. Because I'm a nerd, I got good grades. So I got a grant to pay for graduate school. So because I had a grant to pay for my graduate school, Harvard would take me. And so I went and got my PhD from Harvard. And then after I got my PhD from Harvard, I've been basically spending the last 30 years traveling back and forth to Africa to see in what ways physics can actually help real people rather than just being something that some academic does in a laboratory somewhere.
Now let me ask you. Now, what countries have you visited and been working in Africa?
Well, in 30 years, you can visit a lot of places. So when I started in 1993, the country of Eritrea was newly independent. So I went and I worked in Eritrea for 3 years, and then kept up that collaboration for a while. And then around the year 2000, 2005, I started branching out to other countries. So I did projects in Senegal and Ghana and Tanzania. And more recently, over the last 7 years, I decided I picked sort of the lowest income, one of the lowest income countries in Africa, which is Malawi, and decided that solar has got to have a way of solving poverty in the lowest income places in Africa. And it took us 7 years, but now we have a whole set of products. So we have these solar lights that have these special batteries that'll last 10 years or more. We have the solar pumping systems. We're doing solar electric cooking so that women don't have to breathe toxic wood smoke that gives them respiratory disease. And we're also bringing solar electric vehicles so that people don't have to waste their money on gasoline. But in terms of the immediate impact and a payback that is months rather than a year or two, we find that the solar pumps are it. because the solar pump, the water from the solar pump irrigates a garden, which produces vegetables, which people sell for money. So the pump translates directly into income. And once you have income, then you can start solving other problems. So that's why we're really emphasizing the solar pumps this year. If we can fundraise an extra 20,000 bucks just to get started, we can get 1,000 solar pump systems to Malawi. And the way we do that is we just focus on buying the pump and the hose at a good price at scale. So we send the pump and the hose by the container load. You can fit a pump and hose for 1,000 systems in one 20-foot container. That costs 40 to 50,000 bucks. If we get the pumps and hoses there, you know, worst case, we can convince people to buy the solar panels in the market, right? So we're focused on raising the money by the end of this calendar year to get the pumps and hoses, and then we'll get the 1,000 pumps distributed one way or another.
How can people contribute to this venture?
We have a website. We have two websites. One is called Solar for Africa, solar4 africa.org. And then the other is Women's Solar. So Women's Solar, just one word, Women's Solar, one word, no apostrophe, no dashes.org. And those websites give you more information, and there's a donation link on it. And that over between now and the end of the year, all of our new donations are going to these solar pumps because they really produce the most happiness and the most income with the fewest dollars. So we've got to do it.
All right. Thank you for this demonstration. It seems simple enough, and I encourage everyone that is listening to this broadcast to please contribute. Can you give us those websites again, Robert?
So it's Solar for Africa. That's the word solar, the number 4, and then africa.org. And it's womenssolar.org. So women's, WOMENSSOLAR.org. And both of those will work. And the Solar for Africa tells you about everything, the lights, the pumps, the cookers, and the cars. The Women's Solar is focused on the solar pumps because we distribute the solar pumps to women's groups. So one in rural Malawi, one pump is shared by 5 to 15 women. So basically for 200 bucks, you wind up increasing the income of 5 to 10 women by as a group by more than $1,000 a year.
Thank you, Robert, for this demonstration, and I encourage everyone to contribute to this worthy venture. This is Imhotep Alkebalon with Robert Van Buskirk, Dr. Robert Van Buskirk, signing off.
Thank you very much, Imhotep.